Hello and welcome. This is Mike Mercer from Mercer Quality Consulting, bringing you tutorial number 4 on nonlinear regression in the new Minitab version 16. What I'd like to do is go to the NIST web page and pick up a data set. So I'm going to flip over to Internet Explorer, go to the Google toolbar, and type in NIST nonlinear regression dataset. And there we go. And the very first entry is the nonlinear data set. Now I've done this before, and I would like to pick the second data set. We're root 2. We can see it's an exponential. It has 3 parameters and 54 observations. So we're going to click on that. Here's what it's supposed to look like. I'm going to go to the data file. Data file is here. We can just copy the data. The reason I'm showing you this is if you want to go back and pick up some of these other data sets, you can feel free to do that at this website. I'm in Minitab now, and I'm just going to paste the data in. So now we have the Y and X. And let's go see what that looks like. Let's go to a simple graph. Put in our Y variable and our X variable, which are very handily labeled as Y and X. And yep, that certainly looks like what we saw on the NIST web page. Okay, now let's go in and go into Stat Regression, Nonlinear Regression, and our response is Y. Now there's a number of ways you can enter your function. You can use the catalog, and there are some functions already in here. And any function you put in remains in here, and so you can see my function 1 through 7. Those are functions I've already done. I'm going to cancel that. There's a calculator, so you can go into the calculator and type in any kind of function using all the Minitab functions here. Or you can go directly. Now I'm going to type in directly, but I'm going to cheat. I'm going to sneak back to the NIST website, and I'm going to go up here, and oh, look at this. There's the form of the equation right there. So I'm just going to copy it. I suppose we can right-click and say copy. We can fly back to Minitab, and I can right-click and paste, and there's the expression. Notice now we have B1, B2, and B3 for our parameters. The next thing we have to do is go to the parameters, and you have to stick in some initial estimates, some starting values. Well, let's go back to the NIST web page and look and see, oh, they've got some parameters here. So we're going to do the start one, which is B1 equals 0.1, B2 0.01, and B3 0.02. So let's go in there and put those in. So we got 0.1 here, 0.01, and B3 0.02. Okay, that's it. That's all you need. You need the form of the equation. You need some initial estimates. You need the data, Y and X. Hit OK, and there we go. There's the fitted line plot. Looks like it fits the data fairly well. Let's go into the session window. Let's maximize the session window and go back and see what we've done here. Okay. Now there's as we look through the data here, we see that there's a couple of algorithms that they use. The most normal one is a Gauss-Newton. If that doesn't converge, they go to a second one. They have 200 iterations, and the tolerance is 10 to the minus 5 here. That's when changes get smaller than that, we say it converges. Here's the equation with the actual values that were found. And here's the estimate, parameter B1, B2, B3, and here's the estimate and the standard error of the estimate. We actually have a form of the equation with the B1, B2, and B3 in it. We have an ANOVA table. Lack of fit. Okay, there's no lack of fit here. And then we've got some other estimates. Well, let's go back and see what the NIST website says. So we got this point 166577. 166576, or rounded off 7. The B2 value is 5.1653 times 10 to the minus third. 5.165 times 10 to the minus third, same number, 12150. 12150. Okay. Now let's even see if the standard deviations are the same. Here's a 383. 383. Looks pretty darn good. Well, that was pretty straightforward, as we can see. What I'd like to do now is go back to the NIST web page and pick up a slightly more complex data set. And we just go back to the web page, and what I'd like to do now is pick up the RAT43 data set, which again is an exponential. This time it has 4 parameters and only 15 data points. So clicking on that link, clicking on the data file, going down, finding the data, right-clicking to copy, alt-tabbing back to Minitab, and erasing the existing data and repasting the data in. Using spaces as delimiters is okay. We now have the X and Y data, 15 data points. Okay, let's go up, go Stat Regression, Nonlinear Regression. And the example from the previous exercise is still in here. Luckily the data is still labeled X and Y, but the formula model that we're trying to model is incorrect, so we're going to go back and copy the model. Again, this is the easy way of doing it. And right now I see that there's some square brackets in here, so when I get this back into Minitab, I'm going to have to replace the square brackets with normal brackets. Minitab does not like square brackets. Okay, now we see there's B1, B2, B3, and B4. In the parameters, so click on the parameters where we have to go and give the initial starting values. Go back here and see what they had. Well, they've got 110, 1, and 1. Pretty easy to remember. 100, 10, 1, and oops. That's 100. Let's use the arrow key. 10, 1, and 1. And let's go OK. Let's go OK here. And it's crunching through the many iterations. And look at that, a very poor fit. Well, this is a deliberate example of that there is a second algorithm in Minitab. And let's go back and start that again. Stat, regression, nonlinear regression. We can go down here to the options button. And in the options button there are 2 algorithms. So let's, instead of using the default, which is Gauss-Newton, let's go to the Liefenberg-Marquardt. So we'll click that, go OK, go OK again, and let's see what happens. Well, that was quick. There's the chart already, and that certainly now looks like it fits. Let's go back and see what the estimates are for the parameters. And for B1 we have 699.642. Let's go back to the website and see what we have here. 699.642 with a roundup. Let's see what the standard deviation is. It's 16.3023. 16.3023. And the rest of the parameters will be the same.